So this is a video key to the nomenclature worksheet. The first thing we want to do with nomenclature is make sure that we go through the whole section in the book, Nomenclature 4.2. Also, we should make sure we review how to designate a chiral center, which is section 5.3. So there are nomenclature rules in summary. We said, first of all, we're going to number one, which is identify and name the parent chain. Remember, we're going to choose the longest chain. If there are two chains of equal length, the parent chain should be the chain with the greater number of substituents. Once we've counted the number of carbons in the longest chain, we'll give it a prefix. Remember, the prefixes are meth for 1 carbon, eth for 2, prop for 3, bute for 4, pent for 5, hex for 6, hept for 7, oct for 8, 9 for non, and dec for 10. Then we'll add the ending to that, ane, which tells us that we're dealing with alkanes. And lastly, if it's in a cycle, we will add the prefix cyclo. So cyclohexane, for instance. The second thing we'll do is identify and name the substituents. So any substituents that are attached to that parent chain, we will name them. And then we will also give a locant to them. So number the parent chain and assign a locant to each substituent. We want to give the first substituent the lowest number possible. So we're going to number that chain to give the substituent, the first substituent, the lowest number possible. If there is a tie, we're going to choose the chain in which the second substituent has the lower number. If there's still a tie, then we'll give the substituent that comes first in the alphabet, the lowest number. And number 3 is we're going to arrange those substituents alphabetically in front of the parent. So we'll place the locants in front of each substituent. For identical substituents, remember we can use the prefixes di, tri, or tetra, and we ignore these when we're alphabetizing. Remember that Turk, tert, and sec and neo are also ignored while we're alphabetizing, but isopropyl is used for alphabetizing. On your own, make sure you review Skill Builders 4.1 to 4.4. So we're going to go through a few examples here. And the first one says, name the following compounds, not taking into account any chiral centers. So we don't need to worry about chiral centers here. So this is a simple alkane. We've got 1, 2, 3, 4 carbons in our longest chain. So remember, number 1 is to find the longest chain of carbons. 1, 2, 3, 4. 4 is bute. And then we're going to add the ending ane. And the next thing I need to do is look at the substituents. So there's one substituent, and that is methyl. And now I need to locate that substituent. So I'm going to number this parent. If I start here at the left, I'm going to get 1, 2, 3, and the substituent would be at 3. But if I start here at the right, it's going to be 1, 2, and my substituent is at the 2 position. So the name of this compound is going to be 2-methyl-butane. Okay, let's look at this next one. It's a little more complicated. We need to find the longest parent chain first. And you can see if we went straight across, this would be 1, 2, 3, 4, 5, 6, 7. That would only be 7 carbons. If I went this way, let's see, 1, 2, 3, 4, 5, 6, 7, 8. That would be 8 carbons. So that's one possibility. And let's get a color here and we'll draw that. So 1, 2, 3, 4, 5, 6, 7, 8. Okay. If I numbered the compound this way, I would get 1. Well, first of all, that would be octane. So 8 carbons. I would have 1, 2 substituents on this molecule. if I number the parent starting here up at the top, that'd be 1, 2, 3, 4, 5, 6, 7, 8. That would also be octane. But now in this case, I have 1, 2, 3 substituents. So remember we said if there was a tie, both of these are octane, that I want to choose the route that gives me more substituents. So I'm going to choose the green route. So my parent here is octane. And now what I need to do is go through and name the substituents. So um, I'm going to name the substituents. This first one is a methyl group. So I've got methyl. The second one is an ethyl group. And the third one is an ethyl group. Okay, so I've got methyl and I've got combine these into diethyl. Now, which way should I number? If I start numbering at the left, 1, 2, 3, 4, my first substituent gets a 4. If I start here up at the top, my first substituent gets a 2. So we're going to start at the top. 1, 2, 3, 4, 5, 6, 7, 8. So my methyl group is at the 2 position, and then my ethyl groups are at the 3 and 5 position. So that's going to be 3 comma 5, diethyl. So the name overall is, oops, now that we have all the substituents, we have to alphabetize them. And we're going to alphabetize them by the E, because remember we ignore the di, and the M. So that means the diethyl will come first. So we've got 3, 5, diethyl, 2 methyl, octane. Okay. Let's move on to the next one here. So this next alkane has 2 different ways we can name it. A simple way to name it is by using the common name for this substituent. The common name for this substituent is tert. Oh, let me erase that. Sometimes my trackpad goes crazy here. Okay, is tert butyl. Okay, remember we need to memorize tert butyl, sec butyl, and isopropyl. So this is tert butyl. If I do that, all I need to do is name this parent first. The longest chain will be 1, 2, 3, 4, 5, 6 carbons. So that's hexane. And then I'll need to number this chain. If I start on the left, 1, 2, 3, 4, my substituent would be at the 4 position. If I start on the right, my substituent would be at the 3 position. So I've got 3 tert butyl, hexane. Okay, so that's using the common name for the substituent. Remember, we did say that that's IUPAC accepted, so that's an acceptable way to name this compound. However, if I number this compound starting up at the top here, 1, 2, 3, 4, 5, 6, my parent is still hexane, but you can see I get more substituents out of this. So at the 2 position, I'm going to have 2 methyl groups, and at the 3 position, I'm going to have an ethyl group. So if I choose to use this method, which is the systematic way, not using that common tert butyl, then at the 2 position, I have 2, 2 dimethyl. And at the 3 position, I have ethyl. Okay, so putting these together alphabetically, remember I ignore the di, so I'm alphabetizing by the E and the M. I'll get 3-ethyl 2,2-dimethyl hexane. Okay, so that is another valid name for this same compound. Okay, and then the last one here of our alkanes. Uh, remember, the parent is going to be the longest continuous chain. In this case, it's the cycle. We've got 5 carbons in a cycle. So my parent, let's go back to the black pen, is going to be cyclohexane. Sorry, cyclopentane. 5 is pent. ANE is the ending, so cyclopentane. Now, how am I going to number this system? I'm going to start numbering the system to give the lowest number to the most amount of substituents that I can. If I start over here on the left, I'm going to get, there's 2 methyl groups. So that would be 1, 1, 3 for my substituents. If I started over here on the right, I would get 1, 3, 3. So I want to make sure that I use the black colored route and I use 1, 1, 3. Okay, so my substituents at the 1 position, I have 1, 1 dimethyl. And at the 3 position, I have an ethyl. Okay, so I'm going to put those in alphabetical order by the M and the E. So we've got 3-ethyl, 1, 1 dimethyl, cyclopentane. Okay, let's look at these next ones here. The next ones have stereochemistry. The question says, name the following 2 compounds, including stereochemistry. So we're going to follow these same procedures that we've been doing. We're going to find the longest parent chain. So we've got 1, 2, 3, 4, 5, 6. That is hexane. And the substituent we have is a methyl group. And remember that we now need to locate that substituent. Obviously, if I started numbering at the right, it would have a much higher number than if I started at the left. So we've got 1, 2, 3. So the name is 3-methyl hexane. However, you notice we have a stereocenter here, and this is chapter 5. So we need to assign the configuration of that chiral center. So when I look at this chiral center here, remember the chiral center has 4 different groups attached. The wedge is pointing out at you. That's a CH3 group that's pointing out at you. The ethyl group and the propyl group are in the plane of the board. The 4th item that's attached to the chiral center is a hydrogen that is dashed. So that's pointing back into the plane of the board. Remember that in order to assign RS, we want the lowest priority group to be pointed away from us. That's the convention. So in this case, the lowest priority group is the hydrogen and it is pointing away from us. So that's priority 4. Okay. The highest priority group is going to be this propyl group over to the right. So we're going to give that 1. Then the next highest priority is the ethyl group. And the 3rd priority is the methyl group. So with that hydrogen pointing back, all we need to do is decide if this is clockwise or counterclockwise. And you can see here that it is clockwise, and that gives us R. So the name of this compound is R3-methyl hexane. Okay. Sometimes they'll put the R in parentheses. It's up to you. You don't have to. Usually that's when we have more than one chiral center. But this is R3-methyl hexane. Okay, on this next one here, we also have a stereocenter. Same parent is 6 carbons. So we're going to write hexane. And then at the 3 position, we have a fluorine. And so that's going to be 3-fluoro. Oops, let me erase that dash. 3-fluorohexane. Okay, but we need to assign the configuration of the chiral center here. Remember, the definition of a chiral center is 4 different groups attached. We have a hydrogen, a fluorine, an ethyl group, and a propyl group. So 4 different groups attached. In this case, our lowest priority group is pointing out at us, which is the hydrogen. And remember that if the lowest priority group is pointing out at us, we can do our normal assigning the chiral center, and then we're going to take the opposite of what we get. So for instance, the hydrogen is priority 4, the fluorine is priority 1. We've got an ethyl group, which will be, or we've got a propyl group, which will be priority 2. And then we've got a ethyl group, which is priority 3. Okay. So ignoring the 4, we're going to start here and we go from priority 1, 2, and 3. That gives us R. It's clockwise. And since it's clockwise, we do look and we see the hydrogen is pointing out at us instead of back. Remember, it's supposed to be back. If it's pointing out at us and we get R, then we simply take the opposite. Okay, so this is S3-fluorohexane. Okay, in the first example, the hydrogen was pointing back, and so we just assigned the configuration, and what we got was R. In the second example, the hydrogen is pointing out at us, so we assigned the configuration, which was R, but we took the opposite. That's a little trick. Okay, so we've got S3-fluorohexane. The last one here says draw the structure for the following. R, 1-chloro, 1-ethyl, 2,2-dimethyl cycloheptane. Okay, so first thing we're going to start with is the parent, cycloheptane. Hept is 7, A-N-E means all single bonds. Drawing a 7-membered ring isn't the easiest thing in the world, but we'll give it a try. We've got, especially with this pen that I've got here, there's my 7-membered ring. I've got 1, 2, 3, 4, 5, 6, 7 carbons in there. And then I've got, I'm going to look at these substituents. So at the 1 position, I have a chloro, and at the 1 position, I have an ethyl group, and then I have 2 methyl groups at the 2 position. So I'm going to put those, the chloro in, and I'm going to put the ethyl group in. And then the last thing that I'm going to do is put the methyl groups in. Actually, that's not the last thing. And this is the molecule, but it does not yet have the stereochemistry in it. I've got 1-chloro, 1-ethyl, 2,2-dimethyl cycloheptane. But I need to put the stereochemistry in here, so I need to assign this as R. So in this case, let's figure out if I made basically, I'm just going to take the lowest priority, I want to point it backwards, and I'm going to see what that is. Is it R or is it S? So the ethyl group here is going to be the lowest priority. If you look at this, the chlorine is the highest molecular weight. Remember, we start at the center carbon and then we move out from there. Chlorine has a molecular weight of 35. The next atom over here on the ethyl group is carbon, has 12. This is 12. This is 12. Okay, so the highest priority group is the chlorine. The next highest priority group is the carbon with the dimethyls on it. The next highest priority group is this left-hand chain, and then the lowest priority group is the ethyl group. So I'm going to take that ethyl group and I'm just going to dash it, which means it's pointing backwards. And I'm going to take the chlorine and I'm going to make it wedged. Okay, now I'm going to assign R or S and I'm going to see if this works. If it is R, then that's great. This is my answer. The chlorine is wedged, the ethyl group is dashed. If it doesn't work, then I'm going to need to reverse the dashes and the wedges. So in this case, we're going to take the green pen and I am going to, um, I've got the 1, 2, 3. And that is clockwise. Clockwise is R. So this is the correct structure. So let's draw that. There's my cycloheptane ring. I've got my methyl groups on the 2 position. I've got the wedged chlorine, and I've got the dashed ethyl group. So this is R, 1 chloro, 1 ethyl, 2 dimethyl cycloheptane. Thanks for watching and good luck with your nomenclature.